So I'm Carsten Veal. I'm from Method. And I'm here to talk to you about a project that we've done in the medical space. This is a head-mounted display to monitor patient data that we're particularly proud of. We call it ViVi, which is Latin for life or alive. And that's really the purpose of this project. So this is really designed for people in the medical field, for anesthesiologists, for paramedics, for nurses that have to keep patients alive and stable. So a really high-stress clinical situation. And what we're really focused on is the patient data and how it's made available to these medical professions in these situations. When you think about all the things that these people have to do and the amount of multitasking that they have to do, we all know multitasking doesn't really work, right? So this morning, my wife was trying to relay a critical piece of information to me while I was looking on my iPhone. I didn't understand a word. And I could have taken the iPhone aside, but if you're in the operating room, you don't really have that luxury. You have to multitask. You have to focus on patients. You have to focus on your team. You have to focus on the data that comes from monitors like this one. So it might be heart rate. It might be oxygen levels. So you absolutely have to multitask, and so we have to figure out ways in which we can make this multitasking more efficient, more effective, so more patients can stay alive and stable in these high-pressure situations. And so what we came up with is a heads-on display, a head-mounted display that I'll talk in more detail, but really the purpose of this is to make the most critical information available contextually in the moment, in the periphery of the medical professional. So when you think about head-mounted displays, you might think about some things like this, like a Google Glass or an Oculus is obviously a very hot category, not necessarily in the medical field, but there's a lot of stuff out there, right? In fact, when we started working on this project, the ask was, hey, can you make us a Google app, right, a Google Glass app? And we realized fairly quickly that that may not be the way to go for a number of reasons. One thing to note is that with all of these off-the-shelf solutions, there's a lot of tools, a lot of sensors that come with the hardware. There's software, there's APIs, so you can do a lot with off-the-shelf heads-on displays. But they're also in many ways a blunt instrument. They're like a Swiss Army knife. They give you a lot of power, but not a lot of specificity. And so what we're looking for, if you forgive the pun here, we're looking more for something like not a Swiss Army knife, but more like a scalpel. So something that's lightweight, that is easy to monitor, easy to replace, but very, very focused on the particular needs. There's a number of other reasons why heads-on displays may not work in a clinical situation in the operating room. If you look at this picture here, let's say this gentleman is an anesthesiologist. He has his hands full, right? So he doesn't have the option to fumble with a button of his Google Glass, not to mention that it's not sterile. He may already be wearing glasses, whether those are surgical glasses or to improve his vision. And so for all of those reasons, including the fact that he may want to focus on the patient at any given time and not look like a you-know-what, the Google Glass isn't really an option. And so we try to come up with a different way. And here's a rendering of ViVi, of this different type of display that we came up with. And it's really, in many ways, an improvement to off-the-shelf head-mounted displays. And we particularly focused on really 4 areas here. The form factor, the optics of the head-mounted display, the way the medical professional can customize the information that's available, and then the fourth one is really the rendering or the visualization of the data. So this kind of close-up shows you a little bit about the form factor. So this sits on a strap, on a head strap, so you can firmly attach ViVi to your head. And then it's a ball joint that you can swivel in and out of your vision. So it's in some ways for the automotive geeks here, it's like a ball joint in automotive steering. So a lot of flexibility, but also a lot of reliability. You can swivel it in all directions if you don't need the device at any given point. And it sits right in front of your eye. It's very easy to use, very unobtrusive, very lightweight. We did a lot on the optical end. This is the actual display unit. We used an off-the-shelf OLED screen, which is very cheap, very easily available, and we picked a monochromatic display. So this is not particularly beautiful in a graphic design sense of a way, but if you consider that this is used in the peripheral of your vision, in the periphery of your eyes, you can process less information, less contrast, less color. So it's specifically designed for this use case. And so it's a standard unit that you can very easily deploy in this device. And then we pick particularly lenses and prisms to allow the ViVi to sit in front of your eyes and extend the focal lengths but at the same time not make you too tired after looking at it for many hours. So the optics was refined in great detail. This is kind of what it feels like when you wear a ViVi. Think about if you picture a tablet and you put it in your hand and you stretch it out, that's roughly how large it'll be within your screen real estate, within your eye. That's how much it takes up. So it takes up a relatively small amount of your vision, but enough for you to be able to process the data. And you can still focus on the patient, focus on the surgical view, do all the things you need to do, but still pick up this information. The data that we want to make available within ViVi, or that the medical professional wants to see, can depend a great deal. So depending on the procedure, depend on whether it's a anesthesiologist or a nurse, they may look at very different type of information, so they can customize it through a companion app. They can pick the frequency with which the data is displayed. They can pick contrast. They can also customize the exact graphical units, as I show in a minute. But it's very, very customizable because we want all the data to be contextual. We don't want any interaction during a procedure or during any kind of critical moment critical interaction with a patient. You don't want to futz with the device, right? And so the display itself uses different modes. I think this is probably the most popular view, which is sort of a basic grid view. We found in our research that doctors want to see numbers. They don't like graphs. They grow up in numbers. In all of their medical education, it's very focused on numericals. So this seems to be like the most popular way to process the information. But you can also look at more of on the left is more of a range. As you might see in a typical weather report, you look at reports or the patient data is there's a range, a recommended range. You can see it's within the range. In the center of the screen, you see just the waves. And again, it's a tiny display. It's like 32 by 64 pixels. There's not a lot of room to play with. So that's more what you might see from a conventional patient monitor. On the right is the display you saw before. So these are different modes that the clinician can pick depending on what they need for the procedure. And this kind of diagram shows basically the whole ecosystem. So the vital signs probe that are sitting on the patient render out the information every half second, every second or so. They're then read out to vital sign monitors. We're not replacing the vital sign monitors, but through the gateway and through the Bluetooth connection, we're basically making that information available on the head-mounted display. That's then how this data is made available in that situation without requiring the medical professional to change their view, to leave the view of the patient or their team, and to focus on a distracting vital sign monitor in the other corner of the room. So that's kind of how the whole thing is set up. So where we are today, this is essentially a high-fidelity elaborate prototype. It's working. We've done basically this. We worked on this project soup to nuts together with our client, Innovation, and together with our parent company, Global Logic. We did the industrial design, the digital design, the branding, the engineering, the optics, so everything that went into this. But any kind of medical device like this has to go through a great deal of clinical testing before it can be approved. There's a lot of regulatory constraints and different regulatory constraints in different markets, as you can imagine. So we're currently in that stage of preparing that commercialization, and we're looking forward to hopefully seeing this in operating rooms in a few years, able to, in fact, truly improve lives and save lives. So that's ViVi. If you want to learn more about it, you can go to method.com or to vivi.vision. Thanks a lot. Yeah, I think we may have time for a question or two. Sure, go ahead.
I'm curious about how you did user testing for it.
You
had problems actually using it in a real environment?
Yeah, I mean, that level of sort of clinical testing is not something we've done, but we definitely approximated this situation. We did research. In fact, our client is an anesthesiologist himself, so there's a great deal of, I should have mentioned that, of relevant experience that we could tap into. We couldn't actually test it in the ER, right? So that, I think, would be the next level of testing. But there's a great deal of interaction with patients, with medical professions that we had in developing ViVi.
Did that influence the design in any way about the fact that you might need to revise it once it actually gets into use?
Well, sure. I mean, I think in the process itself, just like with any other project, we went through a great deal of prototyping from, starting with the more off-the-shelf components to, low-fidelity Lego prototyping to then actually trying to see or simulating what it's like for a nurse or a paramedic in action. So it's changed basically every aspect of this a great deal.
Sterilization an issue in your design?
I didn't hear.
Sterilization.
Sure. I mean, I think you realize that even with I mentioned the fact that you can't use your hands, right? I mean, I think that's one of the reasons why you can't use a traditional Google Glass app, for example. I think it played a role with some of the materials we've chosen in the form factor, and also the way the kind of unit is encapsulated. And it's all kind of designed in a way where it's fairly cheap and it's fairly easy to replace all the components. In the back.
How difficult, I don't know if you've gotten this far yet, but how difficult is it to get the gateway to interface with all the various legacy equipment that you might take?
Yeah, I mean, I think the problem with a lot of these units, these traditional patient monitors aren't designed to be connected. I mean, they were traditionally designed to be standalone units. But there's actually a great deal of work that is happening as we speak in making all of these components more connected, and the leading manufacturers are working very actively on that. So it wasn't that hard, but there wasn't kind of a standard interface. We had to develop it, and especially at the lower level of the stack, there was a fair amount of work we had to do around the electronics and the kind of hardware architecture. I'll take one more question.
Did you do anything special to accommodate for the vision constraints of the user?
The vision constraints of particular users, or
Or if they're nearsighted or farsighted?
Oh, I see.
Are they wearing glasses, or if they have a headlamp on?
Yeah, I mean, I think that's one reason why this swivel came. I think the swivel is a reason to try to kind of accommodate as much as possible, because the lighting situation in an operating room may be very, very different, right? There's very bright lights in one situation, and just the angle in which you place the monitor vis-a-vis the medical professional or kind of the patient affects it a great deal. So some of the flexibility in the form factor was definitely informed by those types of considerations. The lens, I think at this point, is just a standardized lens. I'm not sure we'll ever get to similar as with contact lenses to nearsighted, farsighted type of options. We're not that far along. Thanks a lot.